I will record the session. Okay. Okay. So I think in signal and system one, okay, in signal and system one, basically we have analyzed.
Basically,
Hello.
Sorry, sir. It's a mistake.
Oh, okay, okay. That's okay. Okay. So in signal and system one, basically we have analyzed continuous time signal, continuous time signal, and analog signal. Okay. Can you remember what is a continuous time signal? Can anyone remember? Can anyone remember what is continuous time signal? So if I draw two signal like this is my first signal. Okay. It is like this. Okay. And I have second signal. It is maybe like this. Okay. So which one is continuous time signal? First or second?
First.
This one or this one? First one or second one?
first one.
Yeah. First one. No? This is a continuous time signal. Okay. And this is actually we call discrete time signal. Discrete time signal. Okay. Actually, we are learning in DSP, we are mainly focusing on discrete time signals and digital signals. Okay. Digital signals. Okay. And in signal and system one, we have analyzed about continuous time signal and analog signal. Okay. And this is an example for continuous time signal as well as analog signal. Okay. So here in this module, DSP, digital signal processing. Okay. Digital signal processing, we will be studying mainly discrete time signal and digital signals. Okay. Okay. So I think I think now you can remember that what is a signal, no? Maybe you have already know what is a signal. Okay. Signal is nothing but varying of any physical quantity with another physical quantity. Okay. So maybe two physical, so mainly we are studying about two physical quantities with the two physical quantities. Okay. That means one physical quantity is there. Variable එකක් තියෙනවා. හරි. That can be anything. Okay. Any physical thing like time. Okay. Maybe temperature, maybe pressure. We don't know anything. Okay. And another physical quantity. That is again maybe forces or anything. Okay. Maybe a voltage, maybe a current, anything. Okay. So if this physical quantity, okay, this physical quantity, we called it dependent variable. Okay. Dependent physical quantity. Dependent physical quantity. Okay. And changing with this quantity. Okay. We call this independent physical quantity. Independent physical quantity. Okay. So it can be anything. Okay. Maybe pressure of the air. Maybe pressure of the air changing with temperature, pressure of the air. Okay, so it can be like this maybe. Okay, so this is a signal. The independent physical quantity is the temperature. හරි උෂ්ණත්වය ඒකත් එක්ක මෙයාව වෙනස් වෙන pressure එක. The pressure is the dependent physical quantity. Okay. But in electronics and electrical domain, we are not concerned in these kind of signals. Okay. But in other field, these are the signal. Maybe in mechanical engineering field, okay, this may be a signal, okay, and maybe a force changing with the time. It may be a signal. We don't know. But in electrical domain, okay, in electrical domain, okay, we refer a signal, okay, we refer a signal that is maybe voltage, maybe current or power changing with what? Changing with what? Can anyone remember? Changing with time, okay? This is a time, okay? If the voltage or current or power, okay? Power is nothing but voltage into current, no? VI. This is the power, okay? This is electrical power, okay? This is the electrical power, okay? So if we have plot voltage or a current or electrical power with the time, it is a signal. It is, we call it is a electrical signal, no? It is a electrical signal. Okay, like it is a electrical signal. Okay. So most probably we are concerning, when we are concerning this time, the independent variable is in time, we are normally considering this voltage. Okay. So normal electrical signal is nothing but voltage value changing with the time. Okay. Okay, can you remember that one? Okay. So electrical signal, okay, finally electrical signal means what? Voltage value, voltage. Okay, actually this can be current. Okay, this can be current or power, electrical power. But we are not, normally we are not considering current or power. Most probably we are considering voltage. Okay, voltage that changing with the time. Changing with the time. Okay, this is electrical signal. Okay, so we can see a electrical signal using an instrument. What is that instrument? Can anyone tell? What is the instrument we use to see the electrical signals? Can anyone remember? That is the oscilloscope, okay? Oscilloscope. Have you used oscilloscope in the laboratory? Lab එකේදී ඔකට oscilloscope use කරලා තියෙනවද? Have you used oscilloscope? Ah, yeah. Okay, so I think you are familiar with that one, no? Okay. So oscilloscope, we can see the time varying signal using the oscilloscope. Okay. So Actually, this is so electrical signal normally referred, that is a voltage changing with the time. Okay, so time is the independent variable here. Time is the independent variable here. Okay, time is the independent variable. Variable means it is changing. Okay, independent means we are changing the time. Okay, and according to the time, voltage is changing. Okay, so this is called dependent variable. This voltage is depend on the time. Okay, so that is why we call this is dependent variable and this is independent variable. Okay, if you have any doubt, please ask me. Okay, maybe uh, maybe now you have almost forgot these things. Okay, so if you have any doubt, please ask me. Okay, so anyway, so if the independent variable is time, we call this time domain signal. Okay, we called it time domain signal. Time domain signal. And also we called it waveform. Okay, it is a waveform. Okay, time domain signal, that is a waveform. Okay, so time domain signal or waveform can be seen using oscilloscope. Okay, so I think you have familiar with this. Okay, and sometime, okay, sometime I told you that signal is not the time. So here a time, the independent variable is time. Okay, so the voltage is changing according to the time. Okay, so but this should not be sometime this may be not a time. Okay, make a time make a novenna plan time make a when on කියලා එකක් නැහැ. This it is not must to be this independent variable time. Okay, for some cases we have to use another domain signal also. Okay, and most probably sometime, okay, most probably we like to see a signal in frequency domain also. Okay, frequency domain. That means, okay, that means the independent variable is frequency in this case. Okay, මේ case එකේදී independent variable එක frequency. Okay, so this is frequency. Okay, and this can be a voltage or current or power. Okay, in frequency domain, okay, in the time domain we are normally considering voltage. Okay, time domain එකේ අපි voltage එක තමයි consider කරන්නේ. Frequency domain එකේ normally අපි consider කරන්නේ power එක. In frequency domain, normally we consider power, not the voltage. Okay, so if you plot the frequency with respect to power, sorry, power with respect to frequency, that is called frequency domain signal. Okay, this is a frequency domain signal and we called it spectrum. This is we called spectrum. Okay, okay, so what is the instrument? We can see the spectrum or frequency domain signal. What is that? The waveform can be seen using the oscilloscope. And also we can see the spectrum also. Okay, so what is the equipment? We can see the spectrum. What is the spectrum? What is the equipment or instrument we use to see the spectrum? That is spectrum analyzer. Okay, that is spectrum analyzer. Okay, so please try to remember that we can represent a signal. signal in two ways. There are other ways also, okay? There are other ways also, okay? But at this moment, we will represent the signal in this way, this two way. One is in time domain, okay? Time domain, okay? So normally we consider voltage. Voltage is changing with the time, okay? That is the time domain signal and we called it waveform. We called it waveform, okay? And the other representation is frequency domain. Frequency domain, okay? So normally we consider power changing with the frequency, okay? And we called it spectrum, okay? And waveform can be seen using oscilloscope. Spectrum can be seen using spectrum analyzer, okay? Okay, did you understand this? Actually, I have arranged one lab session to uh, to show you this instrument and to be get familiar with this equipment, but you didn't attend to the labs. So sometimes you said that some of the students said that you are not informed, okay? I don't know what is happening there, but I have scheduled one labs and I have all prepared the lab sheets and I have given, okay? But somehow it is not happen, okay? So anyway, we will try to use this oscilloscope and spectrum analyzer and try to get familiar with this, okay? Then you can understand these things very clearly, okay? So up to this, if you couldn't completely understand, just take the idea, okay? So I will soon arrange some work in the labs, okay? That is not a lab session, okay? Lab session will be arranged and it will be evaluated, okay? You will be given some marks, okay? But we will try to do some labs work also, okay? To see the waveform and you can deal with the signals, then you can get this concept very well, okay? I hope, okay? Okay, so basically we can represent a signal in time domain and frequency domain, okay? So if we consider time domain signal, okay, time domain signal, okay. So if this time, okay, if this time is continuous, this time is continuous. Continuous means, okay, continuous means if you consider two time point, okay, if you consider two time point, okay, any time duration, okay, within this time duration, you have all the points, okay, all the points are there, okay. So infinite number of points are there between these 2 points, okay. That is we call continuous, okay. So if the time is continuous, we called it continuous time signal, okay. So it is like this, okay. So if you consider 2 point, okay, if you consider 2 point like this, let's say that this is T1 and T2, okay. So you can see that between these 2 points, every points are there, every values are there, okay. So we call them continuous values are there. The values are not breaking, okay. Okay. So all the values are there. So you can't count the points, okay. So infinite number of values are there between these 2 points, okay. Okay. So can you remember this one? I hope can you remember, okay. You can remember this one, okay? So here between this T1 and T2, there are infinite number of values, infinite number of time value. Anyone has a doubt with this statement? කාට හරි මේ ස්ටේට්මන්ට් එක තේරෙන්නේ නැද්ද? මෙතන මේ දෙක අතර ඉන්ෆයිනයිට් වැලියු තියනවා කියන එක. මම හිතන්නේ තේරෙන්න ඕන දැන්. If you can't understand, please tell me, okay? So between these two values, there are infinite number of values, okay? And we call this is continuous value. These are continuous value. Continuous value. Okay? So this is a continuous time signal. Okay? So this is, if this is an electrical signal, normally this may be a voltage, no? This should be a voltage. Voltage varying with the time. So this is a continuous voltage signal or continuous electrical signal. Or we can say continuous electrical waveform. Okay. So this is a continuous signal. Okay. This is a continuous signal. So, and if the time is not continuous, okay, if the time is not continuous, okay, let's say that again voltage signal, voltage changing with the time, okay. So if the time is not continuous, that means if you choose any two interval, okay, you will have finite number of values, finite number of time values, okay, 2 or 3 values, maybe 100 values, but it should be finite, okay, countable values, okay. That is called discrete signal. So that is the time is discrete, okay. That means time is discrete, okay. So between this T1 and T2, the time between T1 and T2, these are time, okay. So this may be 1 second and this may be 8 seconds or something, okay. So between these two times, there are finite number of value, finite number of value, okay. Finite number of values are there. That means we can count them, countable. එකක් හරි දෙකක් හරි 100ක් හරි කීයක් හරි we can count them, okay. So that is called discrete value, okay. So that time is discrete and we call this discrete time signal, okay. So we called it discrete time signal, okay. So the signal is maybe look like this one, okay, maybe like this one, okay, we don't know, okay. So if you consider this T1 and T2, there are 1, 2, 3, 4 times, okay. These are the time points, okay. This is T1, another time point is there, another time point is there, maybe another time points, okay. So you have countable time points, okay. So this is discrete time signal, okay. So this is a discrete time signal. Okay. Then what is an analog signal? What is analog and digital signal means? What is analog and digital signal means? Can anyone explain this? What is analog signal? And what is a digital signal? Can anyone remember? So discrete time and continuous time, we classify this signal based on the time axis. Based on the time axis or time value. Okay. We classify it the signal as discrete or continuous based on the time value. Okay. And how can we classify a signal as analog or digital? Based on what? Based on which value? Can anyone tell? Can you answer that question? So you can see that discrete value, discrete signals, okay? So this is signal, okay? Voltage changing with the time, okay? So this voltage, the time axis is continuous here, okay? And we called it continuous time signal, okay? And in this case, time axis is discrete, okay? There are countable number of points, okay? Here the uncountable number of points. Here you have countable number of points. Here you have countable number. Here you have uncountable number of points. Okay. We call this continuous time signal based on the time value. Okay. And we call this discrete time signal based on the time axis or time value. This is time axis. Okay. Time akshay. Okay. This time axis. Okay. And can anyone tell me how we can classify a signal as digital or analog? Based on which? Digital or analog? Based on which parameter? It's a time parameter. Okay. Discrete and continuous, we classify based on the time value. This one, which value? Can anyone remember? I think we have discussed this in signal and system 1 under signal classification. මතකද? Signal classification යටතේ අපි මේවා ගැන කතා කරා. Signal classification. ඒ කියන්නේ එක එක විදිහට අපි signal බෙදුවා. No? We classify a signal based on different parameters. Discrete and continuous, analog and digital, periodic and non-periodic, okay, energy signal and power signal. I hope maybe you can a little remember. Okay. Okay, actually this analog, we classify a signal as analog or digital based on the amplitude, based on the amplitude value. What is the amplitude? What is meant by amplitude? මොකක්ද amplitude එක කියන්නේ? අපි අහගෙන නේද ඉන්නේ? මොකක්ද amplitude එක කියන්නේ? Signal එක amplitude එක කියන්නේ මම නිකන් signal එකක් අඳින්නම්. I will write a signal. Okay. So this is a signal coming from a motor. Okay. Coming from a turbine. Okay. AC turbine. Okay. So AC turbine is there. Okay. And if I rotate this turbine, okay, and I have two terminals, I can get this kind of signal. Okay. From this turbine. Okay. So this is a electrical signal. ඔකට ගෙදරට කරන්ට් එක එහෙම එන්නේ මේ වගේ එකක් නෙවෙයි ටර්බයින් එකක් කරකවලා එන්නේ නේ. හරි. එතකොට මේ වගේ සිග්නල් එකක් තමයි හැදෙන්නේ. හරි. So this is actually a electrical signal. That means voltage. Okay, most probably voltage is changing with the time. Okay, the time is changing. The voltage is changing according to the time, like this. Okay, so you have first you have zero voltage, no voltage. Then voltage is increasing up to some level. Let's say that this maximum level is 120. Yeah. Okay. So your answer is somewhat correct, but it is not completely correct. Okay. Uh, okay. Okay. I will explain. Thanks for the answer anyway. Okay. So if I take this one, okay, so this is 120. So this is plus 120. This is minus 120. Okay. So this minus means the polarization is changed. Okay. So in this case, the polarization, this may be a plus terminal and this may be a minus terminal. Okay. So that means the current may be flowing from here to here. Okay. In this way. Okay. But in this curve, at this curve, the polarization is changing. So at this time, this will be plus, this will be minus. Okay. So the current is flowing in this direction. The voltage polarization is changing. It is just like a battery. Okay. So if the battery is like this, okay, if you have connect the battery, this is a plus and this is a minus. Okay. So the current is flowing in this direction. No, in this direction. Okay. So if you change the polarization, that means the terminals. So at that time, this will be minus, this will be plus. Then the current is flowing in this direction. Okay. So here the minus refer the polarization. Okay. This minus refer the polarization. Okay. Current direction or voltage direction. Okay. Voltage direction. Okay. So time, you have time. The voltage is changing according to the time. Okay. Yeah. Yeah. Okay. So I think your answer is more accurate. Okay. 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 Now the voltage is changing like this, like this. Okay. Let's say that the time here is the time here is this time. I will take this time 0 point 0.002, 0.027, 0.027. Okay. So this time is 0.027 and this is voltage is 120. Okay. Okay. Now tell me what is the amplitude of this signal? This is a voltage signal. Okay. This is a current or voltage signal. This is a voltage. Okay. So the CEB supply to your home. Okay. So you will get this kind of voltage signal. Okay. We call this actually AC signal, alternative current signal. Okay. Okay. So, so this kind of signal will come to your home through the CEB. Okay. Yeah. So now tell me what is the amplitude of this signal, electrical signal? Can anyone identify what is the amplitude? What is the amplitude of this signal? What is the amplitude of this signal? This is a continuous time signal, no? It is a continuous time signal. Oh, it is actually a waveform, continuous time waveform, because it is changing with the time. The voltage is changing with the time. So time is the independent variable. We called it waveform. Okay. So using the oscilloscope, you can see this. What is the amplitude of this signal? Okay. Actually, most of students think this 120 is the amplitude. Okay. 120 is the amplitude. But actually, that is not the amplitude. Okay. That is the peak value. That is the peak value. Normally, we refer that VP, the peak voltage. Okay. And the value between these two, that is 240, no? 120 minus 120. This is 240. This is we called peak to peak value. Peak to peak value, normally referred as VPP. Okay. So this is VP, peak value, and this is peak to peak value. Okay. Okay. This is peak to peak value. Okay. So the difference between the highest and lowest value, that is peak to peak value. Okay. Actually, the amplitude means the voltage value. The voltage value, y-axis, we normally referred as amplitude. Okay. So this is actually a voltage value. Any voltage value, that means the y-axis value. Y-axis value, we normally referred as amplitude. Okay. So this signal amplitude is changing, no? Sinusoidal. This amplitude is changing sinusoidally. මේ signal එක amplitude එක sine signal එකක් වගේ තමයි වෙනස් වෙන්නේ. වැඩි වෙනවා අඩු වෙනවා වැඩි අනිත් පැත්තට මාරු වෙනවා polarization එක මාරු වෙනවා ආපහු අඩු වෙනවා වැඩි වෙනවා ඔය වගේ. හරි. එතකොට මෙයාගේ amplitude එක change වෙනවා. හරි. එතකොට මෙයාගේ අපිට එක amplitude level එකක් නෙමෙයි මෙතන amplitude level ගොඩක් තියෙනවා. නේ? So we can't say that one amplitudes are there. There are several amplitudes. Okay. So if I ask you this question, okay, tell me the amplitude of signal at 0.01 second and 0.005 second. Okay. මේ S එක පහ වගේද වෙන්නේ කට්ටියට. කට්ටිය ගිය පාර එක්සෑම් එකේ S එකක් පහ වගේ දැකලා තියෙනවා ගොඩක් කට්ටිය. සිග්නල් ඇන්ඩ් සිස්ටම් වල මේ S මේ සෙකන්ඩ්. හරි මේ පහ. Okay. Okay, tell me the amplitude of this signal at 0.001 and 0.005 second. Okay. Tell me the amplitude. This is the first and second. For first cases and second case. Okay, take 5 minutes and tell me the value. Take 5 minutes and tell me the value. Hello, have you found the answer? What is the voltage or amplitude at 0. What is the voltage or amplitude at 0.01 second and 0.005 second? This point is 0.02 second, no? Okay. This point is 0.02 second. And which point is the 0.01 second? Half of this point. This one, no? This point is the 0.01 second point. Okay. What is the voltage at this point? So what is the voltage at 0.01 second? Please tell me. මේ මුළු සර්කල් එකම 0.02යි සෙකන්ඩ්. එතකොට ඒකෙන් භාගයක් නේ 0.01ක් කියන්නේ. ඒ කියන්නේ මෙතන. මේ සර්කල් එකෙන් භාගයක් මෙන්න මෙතන. 0.01 point කියන්නේ මෙන්න මේ point එක. So what is the voltage at that point? Voltage or amplitude? Yeah, that is 0. Okay. So amplitude is this level is 0. 0 volt. Okay. Then what is the amplitude at 0.05? Half of this one, no? Half of this one, what point that is? What is the amplitude of that point? Yeah, that is 120, okay? That is 120 because the half of the circle is here, middle here. And you will get the maximum peak value of them at the middle of this half circle. At the middle of this half circle, this is the half circle. At the middle of this half circle, you will get the peak value. Okay. So this half circle is 0.01. Half of this half circle is, that means this point is 0.005. Okay. So the voltage is 120 or the amplitude is 120. Okay. So the amplitude is changed. Okay. So amplitude is the y-axis value. That is the y-axis value. Okay. So normally for a waveform, we choose voltage as the y-axis. Okay. So normally, if you consider electrical signal, amplitude is the voltage value. Amplitude is the voltage value or y-axis value. Okay. So we classify a signal as analog or digital based on the amplitude or voltage value. Previous case, you consider the time value. Okay. Previous case, you consider this value, time value. If the time is discrete, it is a discrete time. If the time is continuous, it is a continuous time signal. But here, you will consider the amplitude value. Okay. So if I write a signal like this, let's say that I have signal, write a signal like this. Okay. So definitely this is a continuous signal because the time is continuous. Okay. Now, if you consider two voltage point, let's say that this is one amplitude and this is another amplitude, V1 and V2. What can you say about these 2 points? How many points are there? How many values are there between this V1 and V2? මේ V1 එකයි V2 අතරයි කීයක් values තියෙන්න පුළුවන්? Hmm? How many values between this V1 and V2? This is the amplitude value. No, this is one amplitude and this is another amplitude. This is y-axis value. Okay. So if I consider this signal, okay. So if you consider this point and this point, how many values are there? Can you count the value or can't? Can you count the value or not? මෙන්න මේ point එකයි අතර තියෙන values ටික ඔය කට්ටියට calculate කරන්න count කරන්න පුළුවන්. Yes, there are infinite number of values. Many values, no? Infinite number of values. You can't count them. Okay. Infinite number of value. Infinite number of value. You can't count. Uncountable. Okay. So if the amplitude levels are uncountable, that means it is continuous in amplitude domain. No? It is continuous. The amplitude level, amplitude's values are continuous. Okay. So it is called the analog signal. Okay. It is called analog signal. Okay. So if you consider analog signal, if you take 2 points, okay, if you take 2 voltage points and between these 2 voltage points, the values are uncountables, we called it a analog signal. Okay, the voltage points are uncountable. It is a analog signal. Okay, and what is a digital signal? If you have countable voltage levels, okay, if you have countable voltage level like this, okay, consider this kind of signal. Okay, so you can see here the voltage value have a value, some value, maybe 2 volt. This may be 3 volt. This may be 4 volt. This may be 5 volt. Okay. Again, this may be 4 volt. This may be 3 volt. This may be 2 volt. Okay. And this may be minus 1 volt. This may be minus 2 volt. This may be minus 3 volt. Okay. So you can see the signal is like this. Okay. You can see that there are countable values. If you consider the amplitudes or voltage, there are countable voltage values. Okay. The limited voltage value, limited voltage value, limited voltage values. Okay. So that is called a digital signal. Okay. So that is analog and digital. Okay. So basically, up to this level, you should know what is a signal. Okay. What is a signal? Now you should know the understand. Now you should know how to explain this. Okay. Then what is the electrical signal? What is the electrical signal? Electrical signal is time varying voltage, current, or power. Okay. And how we can represent a signal? How we can represent a signal? Okay. The signal representation. Time domain representation and frequency domain representation. We call this is a waveform, and we call this as spectrum. Okay. And you should know basically these 4 kind of signal. Continuous signal. What is a continuous signal? What is a discrete signal? Okay. Then what is an analog signal? And what is a digital signal? Okay. So you should know these things basically. Okay. So I hope you know these things already. Okay. So if you have any doubts in these sections, please ask me. Okay. Or send me a mail or send me a message, anything. Okay. So try to understand this concept first. Okay. Otherwise, you can't follow this course very well. Okay. So these are the basic things you should know. You should very thorough. Okay. මේවා හොඳට ඔකට්ටිය දැනගෙන ඉන්න ඕන. හරි? Right. So if we have this, now I think that you have already this knowledge, okay? I hope you have already this knowledge, and I gave you a little refresh here, okay? So if you have any doubt, please ask me, okay? Then I can try to explain. I can try to clear your doubts, okay? If I can't answer the question, we can also ask Dr. Udesh, okay? Because Dr. Udesh is is also here. Okay. So if I couldn't answer any question, we can get the help from him. Okay. So ask any question if you have. Okay. Okay. Don't hesitate to ask a question. Okay. So sometimes you think that it may be a foolish question. Okay. ඒක මෝඩ ප්‍රශ්නයක් කියලා හිතයිද එහෙම එකක් නෑ හරි question නම් question හරි ඒකේ අය මේ නුවණක්කාරකමක්වත් මෝඩකමක්වත් නෑ හරි ඔයාට දෙයක් තේරෙන්නේ නැත්නම් ඒක question එකක් හරි if you can't understand anything that is a question okay so you should ask it හරි ඔයා ඒක අහන්න ඕන then you can clear the doubts okay and most importantly if you are asking the question, your communication skills will be improved, okay? If you are asking the questions and answering the question, okay? So that will be very helpful to improve your communication skill. Improve your communication skill. This is very important, okay? මේක සෑහෙන්න වැදගත් ඔය කට්ටිය ඉන්ඩස්ට්‍රි එකට ගියපුවාම කවදා හරි ඉන්ජිනියර් කෙනෙක් විදියට හරි ඔයාට අනිත් කට්ටියත් එක්ක කමියුනිකේට් කරන්න පුළුවන් වෙනවා හොඳට හරි okay thank you Anik okay so you should be able to communicate with others okay and for example okay Chinese engineer if you are a Chinese person okay they have technologies okay Chinese person have technologies okay and technologies those technologies are in their language okay ඒවා ඒ කට්ටියගේ language එකෙන්ම තියෙනවා හරි so the Chinese engineer doesn't want to know the English very well හරි ඒ කට්ටියට ඉංග්‍රීසි ඉගෙන ගන්න කියලා අවශ්‍යතාවයක් නැහැ Chinese engineer කෙනෙකුට because the knowledge is in their language okay the knowledge is in their language okay they have the technology okay but if you are Sri Lankan engineer we have to okay the same as me okay every engineer okay so you are engineering undergraduate okay you are still engineering undergraduate but one day you will become an engineer okay maybe not as a fresh engineer okay maybe first you have to start your career as an assistant engineer or engineering executive okay but after 2 or 3 year experience you can become engineer definitely okay then so in Sri Lankan okay we don't have technology okay අපිට technology එකක් නැහැ the technologies are not in our language Tamil or Sinhala okay we don't have Tamil books okay we don't have Sinhala books okay all these are in English okay and also you have to communicate with the other countries okay maybe China maybe with China maybe with India maybe with England maybe with American okay but they can't communicate with the Sinhala no with Sinhala so definitely you have to as a Sri Lankan if you are doing Sri Lankan engineering okay if you are try to become engineer in Sri Lanka you have definitely you have to improve your English knowledge also okay that is very important okay because all the manuals are in English okay if you get because we don't have any equipment okay all the equipments we are getting from other countries okay so the manuals are if you consider for example if you consider transistors are not manufactured in Sri Lanka if transistors are manufactured in Sri Lankan company maybe the manual is in Sinhala no but those are not manufactured here okay so if you want to know about the transistor specification you should know the English okay so that is very important okay so try to speak with me, then it will increase your English knowledge and the communication skills and also the DSP knowledge. Okay. So, so it will help you in different way. Okay. If you are talking with me, if you are asking the question, and if you are answering the question, okay, that is not only improve your di digital signal processing knowledge. Okay. You will get other benefits also. Okay. Okay. So please remember it and try to interact with me as much as possible. Okay. That is very important. Okay. Okay. Now we have another 30 minutes now. Okay. So we will go to our subject. Okay. That is DSP, digital signal processing. Okay. Actually, I think you have idea what is signal processing. Okay. As electronic engineer, as electronic engineers, okay, engineers, okay, not only electronic engineers, okay, maybe a control engineer, maybe a civil engineer, okay, any engineering field, you have to deal with signals, okay, because I have already told you that signal is not a voltage variation. It can be any physical quantity, okay. So in in every field, the signals are very important, okay. So in electronics, as an electronic engineer, okay, or electrical engineer, okay, so you have to deal with signals every times, okay. You have to deal with signal, okay. So if you consider a simple circuit, electronic circuit, this is the most simplest circuit, no? We have learned with the switch, okay. This is a bulb, this is a battery, and this is a switch, okay. So if you close this switch, the electrical signal will flow, okay. So you can see that this is the most simplest electronic circuits, and it is also working based on the signal, electrical signal. Okay. So you can explain these circuits and you can analyze these circuits based on the signal, no? Okay. So everything's are the signals. Okay. So you have to manipulate, analyze. Okay. You have to manipulate. Okay. And analyze. Okay. And maybe you have to create, okay, signals, most probably, okay, most probably. That is normally a signal processing, okay, manipulate, analyzing, and creating a signal. If you are dealing with the signal, that is a signal processing. That may be not the definition, okay. If you want to see the definition, please Google, okay. But that is the idea, okay. That is the idea. You can explain it like this, okay. Manipulating and creating, manipulating and analyzing a signal. Okay, that is the signal processing actually. Okay, so uh, using electronic circuits also, we are doing many signal processing things. Okay, one thing is storing a signal. That is also a signal processing part, storing a signal. Then you have to sometime filter in the signal. Okay, you maybe have amplifying the signal. Okay, sometime so that kind of, there are many things, okay. So these are signal processing things, okay. Storing, filtering, amplifying, okay. And sometimes you have to do some conversion. Okay. Signal conversion, that is also signal processing. Okay, there are two main conversion actually: analog to digital conversion and digital to analog conversion. Okay, so these are signal processing things, and you have to every time do these things, no? Okay, so signal processing is very important in electronic circuits. If you consider electronic circuit, that is mostly based on the signal processing. Okay, that is nothing but signal processing. Okay, all the things are based on the signal processing actually. Okay, okay. So that is signal processing. Okay, and what is digital signal processing? What is digital means? So I think now you know what is signal processing. Okay, that is creating, manipulating, analyzing, okay, and changing the signal. Okay, work on signal, that is signal processing. Okay, so this kind of signal processing things are done in electronic circuits. Okay, so you already know that nowadays most electronic circuits are digital systems. Most systems are digital systems, electronic systems. Okay, so digital system means they are based on digital signal. Digital signal. What is a digital signal? I have already told you. That means you have very few amplitude levels, maybe countable amplitudes level like this. Okay, that may be 2, that may be 3, that may be 4, that may be 5, that may be 8, that may be 100. Any countable amplitudes level or voltage level. Right? Okay, so how many signals levels normally we are using? Most probably in digital signals, how many uh, voltage level we are using? I think you know the answer. Okay, what is the answer? Normally, how many voltage levels we are using in current digital system? For example, consider your phone. Okay, consider your phone. That is a digital instrument. Okay, so you will have a digital signal. So inside the phone, okay, there are many conversion and processing. Okay, signal processing things. Okay, okay. So once it convert to digital signal, okay, and then the processing is done in digital domain. Okay, so how many voltage level we use? Yeah, yeah, that is the correct answer. Okay, how many voltage are there? How many? Kochchara voltage? Yes, that is 2 voltage levels. Normally it is 2 voltage level. Okay, so if you consider signal, okay, if you consider signal, okay, now most probably in most digital system, you are dealing with 2 amplitudes level, most probably. Okay, almost in every digital system, you are most probably dealing with 2 amplitudes level. Okay, so that may be 5 and 0. Okay, or that may be uh, 5 and minus 5, 2 volt and minus 2 volt, anything. Okay, we don't know. Okay, anyway, 2 values. Okay, let's say that it is 5 and 0. Okay, so this 5 can be represented using maybe 1, and this 0 can be represented maybe using 0. Okay, so that is, you can represent this signal, digital signal, using 1 0 1 0, using bits. Okay, actually these bits represent a voltage value. 1 represent a voltage value, And 0 is also represent a voltage value. Yes, that is low and high. Okay. Low voltage value and high voltage value. That's true. Okay. So that is a digital signal. No? That means countable voltage levels are there, only two. Okay. So that is a digital signal. Okay. And why we like to do signal processing, digital signal processing? Actually, there are many advantages. Okay. There are many advantages of digital signal over analog signals, analog system. Okay. Digital system over analog systems. There are many voltage. Here, digital system use low power. Here, high power. Okay. In digital system, the design is very easy. Design is very easy. But analog system design is very hard. Okay. For example, ඔකට්ටයට කීවොත් එහෙම ලොජික් සර්කිට්ස් පාවිච්චි කරලා මොකක් හරි සර්කිට් එකක් හදන්න කීවොත් එහෙම ඔකට්ටිය කරන්නේ අර ට්‍රුත් ටේබල් එක ගහලා 1010 හොයලා ලොජික් සර්කිට් එක ගහුවාකින් හරි හැබැයි වාට කීවොත් එහෙම ට්‍රාන්සිස්ටර් රෙසිස්ටර් ටිකක් ඉන්ඩක්ටර් ටිකක් අරගෙන සර්කිට් එකක් ගහන්න කීවොත් එහෙම වාට මේ 1010 කරන්න බෑ මේ ට්‍රාන්සිස්ටර් වල රෙසිස්ටර් වල ඉන්ඩක්ටන්ස් වල ප්‍රොසෙස් එක ක්‍රියාකාරීත්වය ඒ වගේ තියෙන රෙස්පොන්ස් ඔක්කොම දැනගෙන ඉන්නවා සිස්ටම් එක ඩිසයින් කරන්න. හරි. So that means that is very hard. Okay. So if I ask you to design a system using a logic circuit, logic component, XOR, NOR, XOR, OR and NOT gate and XOR gate. Okay. So if I ask you to use these gates and ask you to design a system, what you have to do is you can get the outputs combination. Okay. Based on the output combination, you can construct the truth table. Then you can design the circuit very easy. But if I ask you to design a circuit using a transistor, resistor, and inductor, and capacitor, or maybe with the op-amps also, so it will be very hard. Okay, you should know the operation of the transistor very well, the response, high frequency response, low frequency response, all things you should know. You should be expert. Okay, otherwise you can't design an analog system. That is very hard. Okay. So in digital system, design is very easy. But here design is very hard. Okay. And the processing is also very easy. Okay. Here the processing is very hard. Okay. So there are many advantages of digital system over analog system. So most probably we are using digital system now because of this advantage. Okay. Actually, most probably this is the, I think this one is the most significant advantage. Designing process is very easy. Okay. But here the analog system designing process is very hard. Okay. So if I ask you to design an analog oscilloscope, okay, analog oscilloscope, we can't do it. Okay. Maybe our professor also can't do this. But if I ask you to design a digital oscilloscope using an Arduino board or something, you can be construct that one very easy. Okay. Even a student can do this. Engineering student can do the design. Okay. But the analog design is very hard. Okay. So you should be a very sophisticated expert to do the analog system design. Okay. So I think that is the reason හරි හරි විනාඩියක් ඈ. හරි. Okay. So so that is that is why we are most probably we are using digital system over analog system. Okay. I think you got the idea. Okay. So we are like to do the digital signal processing, digital processing. So it will be very easy. Okay. It will be very easy. So that is why most probably we are dealing with the digital signal processing. Okay. So you already know that normally in a digital signal, okay, nowadays digital system use the signal with two amplitudes levels. Okay. Okay. So now one thing you should know. Okay. Okay. Anyway, we will stop the session now, okay? Because here it is hardly thundering. Right? So I think you got the idea. Okay. So next Monday, can you come to the campus to do a because we have missed 2 or 3 interaction session, no? Interaction session. Okay. So can you come next Monday to the campus? Next Monday. Because I need to show you something in the labs. Okay. So next Monday, I can't remember your ref give me a time slot. Okay. You are free. Monday ඔකට කොයි වෙලාවද free වෙන්නේ? 11 එක ඔකට free හරි මොකක් හරි එහෙම එකක් කියව. අර මතක හැටියට 11 to 1. Okay. So ඔකට Monday වල 11 එක එන්න campus එකට. එතකොට මම මෙන්න මේ ටික පෙන්නන්නම් ඔකට. හරි. මේ ඇනලොග් සිග්නල් අර ස්පෙක්ට්‍රම් එකෙන් මැලෙන හැටි ඔසිලොස්කෝප් එකෙන් බලන හැටි අපි ඒවා පොඩ්ඩක් බලමු. හරි. හරි. අපි දැන් සෙෂන් එක නවත්තමු. එකට එක දෙයක් කියන්න ඕන. Okay, I should tell you one thing. Okay. Normally the real world is analog. Okay, real world is analog. Okay. And but we are like to digital processing. Okay, we are like to digital processing. Okay. Then again we have to give the output to the real world. So again it should be analog one. Okay. So the real world parameter, for example, let's say that you are talking to a microphone. Okay. You are talking to a microphone. Okay. Oh, then I will upload. Okay. Okay. I will upload the session. Okay. So if you are talking to the microphone, okay, it will create an analog signal because your voice is normally analog. It is a real world signal. That is analog signal. Okay. Then if you want to digitally process it, you have to do the conversion. Analog to digital conversion first. Then you can process it digitally. Okay. So you are converting this analog into a digital signal. Okay. Then once you want to get the voice back, okay, you have to send it to the speaker. No? To send it to the speaker, you have to use the analog signal again. Okay. So you have to convert this digital process signal into an analog signal so that you have to use the digital to analog convert. Okay. So this is the normal process actually. Okay. In digital signal processing, this whole process we are using. Analog to digital conversion, digital processing, digital to analog conversion and output. Okay. So we will study on these things. Okay. So we will see how to do the analog to digital conversion and digital to analog conversion. Okay. Then we will see how we can process the signal in digital way. Okay. So those things we will try to learn. Okay. So anyway, we will now stop. Okay. So if you have any problem, up to line. So I can answer. Okay. Okay. So thank you for participating. Okay. So I will stop the session. Go now. Thank you.